So today we ran into a little conundrum. Do you see that circle with that ground bar going to plus or going to -1 and -2? Well, over here, the red is positive, the black is negative. I had my oscilloscope hooked up like this. So this is the signal source, and this is ground. I hooked up ground to the output signal. Just kind of casually trying to measure the magnetic fields of the two transformers I have here, or the two coils, because I wanted to see if I could pick up the back EMF of one of these massive copper coils. Um, and so, yeah, I fried channel 2 on that amplifier. There's not much that can be done right now. I'm in the process of fixing it. I'm in the process of finding the components. We'll see how that goes. But yeah, if you have a massive coil of wire, you can sense magnetic fields with it. So just for a little demonstration on half of the circuit, I'll get this plugged in here. The oscilloscope fired up in real time. So this is the same configuration I had before on both coils. For this coil, it didn't matter because this is floating in reference to Earth. This one was hooked up to the power amp. Yeah, plus to ground when we have a ground wire right here going to our mixer, and that mixer has ground going over to here. So that's grounded through the signal path, and then this guy is grounded through Earth through the mains cable, and so is this guy. And there's another path through the main service, but neutral doesn't matter in this case. So we blew it up. So when I move this magnet around, I'm just going to like move it around a bunch. You can see when I drop it, we get big voltage spikes. This is just a way to test it. But the goal was to be able to sense this coil with this one. And in doing so, if you get the frequencies right, in the noise you can pick up the human body's frequency. And that's ultimately what I was trying to do here, is try to get a coherent picture of the human body through meditation. But careless mistake, we blew her up. And you say, well, some of you in the comments section are going to be like, that's a massive inductor. You need a capacitor attached to that. Well, no, this amplifier can indeed handle reactive loads and unbalanced loads. It also has short circuit protection. But this was not a short circuit. Well, it should be, but I'm not sure why it didn't pick up as one, because if we go back to the schematic over here, we see, wait for it, we see the chassis ground right there, that symbol. But if we go over here to the power supply section, we see that all the way over here. So right there, right in the middle there, we see another chassis ground symbol. And then that goes through some filtering and then through a transformer. And that, oh, focus, you fuck. That white wire coming off there, that is our common ground for our circuit ground. And if we go all the way over here, we see our voltage rails. Then we come over here, there's our input. Our input's also grounded by the signal 1 indicator. And if we scroll all the way over here, I'm actually going to zoom out for you guys to like 400. You guys probably still can't see this, but so if we look right here, we have our middle connection. That brings us to our transistor arrays. So for all intents and purposes, this should be a short circuit because it's effectively, where are we? We're effectively shorting our input or our positives lead to ground. Now I haven't verified that with a multimeter because I kind of already know what I did, but right now I blew up an amplifier and I let it sit for 5 minutes. I turned it off. I haven't power cycled it. Well, I haven't power cycled it at the wall, but if we go over here, right there we have our power switch, and there's nothing between that and anything else that gives us a protection circuit. Also, we have is an input filter, a MOV, and then our soft start circuit. The soft start circuit is this part right here. I need to zoom in again so we can actually get a good view of this. But yeah, we fucked up. I'm quite frustrated right now because I don't see what went wrong. Because the other channel's still working, so it's not in the power supply section, the soft start or bridge rectifier. I blew up a bridge rectifier, but I was careful about my input signals. And I'm not sure. So I've poured over this schematic trying to figure out where my short circuit protection is, but I haven't been able to find it. I'm assuming it's short circuit protected only in overcurrent based on the MOSFET current or the MOSFET temperature, but I haven't found that circuit yet. I'm not sure what that looks like, but we will keep searching. This puts a damper on things for sure. In fact, it kind of just blows half our facility up. But we will keep looking and searching. And hopefully Crown support, because they actually just have a professional support service, will get back to me. So with that, good day to you, not me, but we will try to fix it.